Hey YouTube, in this video I'm going to be doing the classic Briggs-Rauscher iodine oscillating reaction. This is actually a highly complex reaction where as many as 30 different things can be happening simultaneously. I have a paper that claims 30 things are possible, but they've narrowed it down to maybe 11 or 12 that are necessary for the reaction to work. So this involves three separate solutions that I've already made here. I didn't film me actually making them, so you just have to take my word for it that this is what they are. Solution A, on the left here, is 0.2 molar in potassium iodate and 0.077 molar in sulfuric acid. Solution B is a starch solution that's 0.15 molar in malonic acid and 0.02 molar in manganese sulfate. And solution C is hydrogen peroxide, 4.0 molar hydrogen peroxide. So I diluted down some 35% peroxide that I had to get this concentration. So these three clear solutions I'm going to combine into one, and we'll get to see some really interesting chemistry and color changing reactions. Okay, now on the stir plate I'm going to combine all three solutions together. So first is solution A. To that we'll add solution B, and it doesn't matter in which order this is all done as long as they're all added together quickly, or relatively quickly. And so nothing happens when both of them are together, so we need to add solution C to get the reaction going. And once that's done, you'll see that the reaction starts immediately. Now that color change is pretty amazing, isn't it? So what exactly is happening here? Well, first off, you saw that there was an amber color to it when it started, and then that immediately changes to this blue. And now, if you'll watch, it'll repeat. So the blue clears, the amber deepens again, and once it gets to a certain point, the color change is instantaneous, or nearly instantaneous. So, like I said, the reaction is extremely complex, but I'll try to sum it up for you. So basically, there's two separate groups of reactions, a fast radical process and a slow non-radical process. So both of these processes reduce iodate to hypoiodous acid, HOI, with the radical process doing so at a much faster rate than the non-radical process. So this hypoiodous acid participates in other reactions that transform it to the iodide ion, I-, and free elemental iodine, I2. The amber color is caused by this free iodine in solution. So when the concentration of iodide becomes greater than the concentration of HOI, the iodide can combine with the iodine to form the triiodide ion, which then complexes with the starch and causes that sudden change in color to the dark blue. So as soon as the iodide concentration passes the HOI concentration, the complexing action is immediate and lasts until the iodide concentration falls back down. Once this happens, the radical process shuts off and the non-radical process takes over again. Since this is slower, it does not produce HOI nearly as fast as the radical process, and iodide and iodine are consumed faster than they can be created. So that causes the blue to clear and the amber to fade back to relatively clear. Eventually the iodide concentration drops down low enough for the radical process to restart and the cycle starts over. This continues until the iodate or the peroxide is consumed. So I used 100 milliliters of each of the three solutions, and this oscillated for almost 10 minutes. I sped up this part of the footage so you wouldn't have to sit through the whole thing. And you can probably see that the reaction slows down as it proceeds, and it's finished when it remains at this blue stage. You may also have noticed that it produces some gases too. This is oxygen, which is one of the products of the overall reaction. And now, if you'll look over the surface of the liquid, you can see that it's sort of darkening a bit. And that's because at this point of the reaction, it's pretty much done oscillating, and now it starts producing iodine vapor. And the iodine vapor can collect over it because I've put a petri dish on top of it to sort of contain that, as well as the splashing that's caused by the magnetic stirring. So now all we got to do is try to get rid of this. So let's try to neutralize it. Okay, I've transferred everything to a larger flask for neutralization, and to do that I'm going to add these thiosulfate crystals, sodium thiosulfate. So I'm just going to pour that directly in there and let it dissolve. I've also got this flask capped, again, to keep the iodine vapors in check. You can see them filling the volume of the flask there. Also notice that when I add the thiosulfate, it bubbles a bit. So you have to be really careful, actually, when you're neutralizing this, because it can froth significantly. I've seen this. It gets really mad when you try to neutralize it, so it's bubbled quite a bit on a couple of occasions, and it heats up a lot. So you have to do it pretty slowly so that it doesn't get away from you. You don't want it to heat up too much, because then it's going to drive even more iodine into the vapor phase, and that's really not something that you want to happen. So basically just keep on adding thiosulfate until this blue, purpley black color sort of goes away, and do that quite slowly. Here I just want to highlight how crazy this reaction still is even after it's done. So you can see all the gas that's being evolved at this point. I've added some thiosulfate, and it just keeps on producing lots of gas and heat. So again, I just wanted to highlight that you need to do this slowly to keep this in check. So I've been adding thiosulfate over the course of about a half hour, and now we're finally starting to get close to the end. As you can see, when I swirl it to mix everything around and further dissolve the solid pieces at the bottom, we're starting to see it clear up a bit, which is what we want. But this is where it starts to get frustrating also, because once it clears up, if you leave it alone, it tends to go right back to blue. Now you can see the color start to condense. So the iodine slowly complexes back with the starch to form that blue color again. So I just got to keep adding thiosulfate until it remains clear. Okay, the solution has been completely neutralized now, and it's back to its clear, slightly cloudy color due to the dissolved starch. So this solution now has no iodine in it. It's all been reduced to iodide and is safe to pour down the drain. It's a little bit acidic due to the acids that I used, but all the rest of the components in here are pretty innocuous, and you should just be able to dispose of it with plenty of water. So that's the Briggs-Rauscher iodine oscillator. Thanks for watching. So I did this reaction again at a smaller scale, and you can see what happened after I neutralized it. So the large one is the one that I did in the rest of the video. This small one I did separately, and you can see that it's now so it's really cloudy. It's like a milky color to it, and I've seen that happen a number of times. That's usually what happens, is it gets that milky color, and that should be due to the starch coming out of solution, and it's probably in a suspension now as sort of a colloid. So that's usually what happens. This clear solution is a little bit different, but that's what you get when you do chemistry. Sometimes things don't turn out the way you expect them to.